Okay, I thought I'd talk, do an example and also talk a little bit about working out double integrals over general regions. So suppose we were presented with this problem. Now with over general regions, these regions can be stated within the integral, so sometimes we get things like this, so probably root x to 3 or even something like that, where the functional values are actually written in on the integral, or sometimes we get it like this and we have to work it out. So here, I'm focusing on the region that we're integrating over for the moment. We see that this is the circle with origin at the centre and radius 3, so it looks like this. And we know that to model this, we need to do it in two halves. So we need to have the top is going to be equal, since it's x squared plus y squared equals 9, we know that the top part is going to be y equals square root of 9 minus x squared, and the bottom part is y equals negative 9 minus x squared, like this. Now, the only problem with this is that even though that's all well and good, trying to take the integral here, note that at 0, 0, or in fact anywhere along the axes, this function is undefined. So we can't take integrals over regions that aren't defined. It's equivalent to, trying to take an integral of even just 1 on x or whatever. We can't do it over that boundary there. So be careful with that. Even though, I could plug everything in and do it the same way I'm doing it, and I could get an answer, in the end, it's going to make no sense. So we're not going to do this function. We're going to do, instead, I think we'll just do a nice little x squared. Okay, so what I make this integral become is going to be, so my x, remember the radius is 3, so I'm going to be going from negative 3 to 3 for my x values. For my y, I'm going to be going from this lower half, negative 9 minus x squared to the top half, 9 minus x squared, and then I'm just doing x squared dy dx here. So firstly, integrating with respect to y, I keep my negative 3 to 3 here, and I'm going to just get nice x squared y over the region, 9 minus x squared here, and negative square root 9 minus x squared here, dx. Now, chucking this in, negative 3 to 3, and I have x squared outside of 9 minus x squared, and then minus x squared outside of, then it becomes a plus, so plus x squared out of 9 minus x squared dx. Like this. Now we'll see, the problem is this integral is a little bit hard. But actually, it's one of the standard integrals. So if I look in my book, and I can see there's a standard integral, this is number 31, and it is that the integral of u squared a squared minus u squared du has this value equals u on 8. I could be running out of the video there. But anyway, it's in this book. It's right at here. It's big though. So u on 8 times 2u squared minus a squared times square root of a squared minus u squared plus a to the 4 on 8, inverse sine of u on a plus c. Now that, that's complicated and that doesn't matter. What matters is that we can evaluate it and chuck numbers in. So for the moment, I'll get rid of all that information. And so here, these can be combined, so why don't I just write it here as integral negative 3 to 3 of x squared 9 minus x, and it's 2 of those, 2 times Okay, so this is what I've got, which, yeah, chucking it into my formula here, so I'll write it out for you again. So remembering that a squared is equal to 9, or a equals 3, I'm going to have, so x on 8 outside of 2x squared minus 9 times the square root of 9 minus x squared plus a gives me, a is 3, so it's 3 to the power of 4 on 8 times inverse sine of x on 3, and it's that, so let me just make sure I keep all this separated. And we're taking that over 3 to negative 3. Now, some of these will cancel out. So, if I look here, when x equals 3 or negative 3, this is going to be 0, so I can actually ignore the whole part of this for the entire function, essentially. So what I'm actually going to get here, let me just double check that I'm in focus. Yes, that's one way of handling it. So what I'm actually going to get, so when x equals 3 or negative 3, this becomes 0, all of that vanishes. So I'm just going to have, when x equals 3 here, which gives me 3 to the 4 on 8 inverse sine of 1. And then minus, I'm going to have this when x equals negative 3, 3 to the 4 on 8 sine to the negative 1 of negative 1. Our sine, inverse sine of 1 gives us either pi on 2 or 3 pi on 2. And here, negative is either negative, sorry, so this is just pi on 2 and then going around, etc. This is 3 pi on 2. So I'm going to have 3 to the 4, which I may as well evaluate, is 81. So it's going to be 81 on 8 outside of inverse sine of 1, which is pi on 2, minus here inverse sine of negative 1, which is 3 pi on 2, which gives me 81 on 8 multiplied by negative 2 pi on 2, so negative pi. And that hopefully should be my solution. So some key things to keep in mind is, we're going to come across integrals sometimes that we can't use our methods of solution for, so it's good to use that standard table of about 100 integrals to go through that. Keep in mind when we have functions that aren't defined in certain places, because then all of our rules, etc., mean nothing, and just, being able to find the regions and calculate those things is important too. Okie dokie.